All right, welcome to the first example of section 6.4. In this section, we're going to be looking at the graphs of both exponential and log functions, and we're going to be looking at transformations of the parent functions and how transformations are written and expressed in function form. So first, before we get into these specific problems, I want to do a quick reminder. So the parent function of an exponential function is just f of x equals b to the x power. Now remember, b can be any constant. So there's not one specific parent function. It's not like 2 to the x is the parent function or 3 to the x. The parent function is any constant to the x power. Okay, so, and the same for our log function. Our log is just f of x equals log base b of x. Log base b of x. These are both our parent functions. Okay, and again, b can be any constant. So when we're talking about transformations, it's important that you understand, first of all, what your parent function in that problem is and what changes have been made. So if you look back in your journal, you see that under the core concepts for this section, all of the different transformation rules are written down. Now you're going to notice these are exactly the same as all the other transformations that we've done throughout this year. So it's the same as transformations to absolute value, same as transformations to quadratic. All of them are the same. So you'll notice you've got your translations. So if you add or subtract a value to your function, it's a vertical translation. Add or subtract to your input, it's horizontal. Now note that because it's x minus h, this is where you have to remember your shifts left and right, you have to look at the opposite sign. So for example, 4 to the x plus 2 power is actually a shift 2 units to the left. 4 to the x minus 3 power is a shift 3 units right. You've got your reflections, same rules apply. You've got your horizontal stretches and shrinks, same rules. Now logs, same exact rules apply here as well. Okay, so these pages are here for your reference if you need them. Okay, so now let's look back at this first problem. So we want to look at our parent function is 1/2 to the x power, and our transformation, our transformed function, is 1/2 to the x minus 4. First thing you have to do is identify what change was made. In this case, we've got our parent function, and we just simply subtracted 4 from it. So since this is in the form f of x plus k, in this case k is -4, that means that it would be a shift 4 units down. Now to graph that, I'm not going to go ahead and make a table and everything for you, but you guys know the way that you would do that is you would simply just make an xy table of your parent function, and for -4 you would just shift everything 4 units down. So f would be your parent function, and because we shifted down 4, you would go down 1, 2, 3, 4, and G, your red line, would be your new graph. All right, now the second example, we look at another transformation. Here, we've got more than one transformation that's taking place. So notice, in this case, we're looking at another exponential function, but in this case, our parent function is e to the x power, and our transformation is e to the x plus 3 power, and that whole thing plus 2. So when you have multiple transformations, you have to make sure that you go slowly through and identify each one individually. So in this case, we're doing two things. We are adding 3 to the input and adding 2 to the entire function. Now, because this is actually for our input, if you remember, it's x minus h. So plus 3 is really x minus -3. So this is actually a shift 3 units in the left direction because this is a change to our input. The plus 2 is a shift 2 units up because that is a change to our entire function. So in this example, we are moving 3 units to the left and 2 units up because our h value is -3 and k is plus 2. Now, to graph that, again, you would just look at your parent function, f, which is blue. This is e to the x power. And to make your graph, you simply just apply the transformation. So 2 units up and 3 units to the left. So that's how easy it is to identify and graph transformations. Remember to review all of the different rules. So for example, reminding yourself, are you changing just the input or are you changing the entire function itself? And then identifying each one of those.